Hey, what's up guys? In this video I am going to discuss with you the depth first search algorithm. It is a graph traversal algorithm. So let's start. Now this is the graph and we need to traverse it using the DFS algorithm. Now for proceeding with the DFS algorithm we need an empty stack. Now as you know, stack is a data structure in which you can add an element or you can delete an element from it only through one side and the other side remains closed or bounded. Okay, so we need a stack for that, an empty stack, okay, and an output queue. Okay, so now this queue is not literally the data structure queue, but we call it the queue. Okay, so this is the empty stack and this is the output queue. Now what we will do, we will go to each of the nodes, okay, and search for its adjacency. Okay, that is the nodes which are adjacent to the node at which we are currently present at, right? So let's start with A. So we will push A into the stack. So A is pushed into the stack and we are writing A in the output queue. Okay, and in the graph we are marking it so that we can understand that we have already visited A. Okay, so this was step 1. Now step 2 is searching for the adjacent nodes of A. Now as we can see that C and B, okay, so C and B are adjacent to A. Okay, now we can take any of those two adjacent nodes. So for instance, let's take C. Okay, so we will push C into the stack, so A and C, and we will write it in the queue, that is AC, and mark it as visited. Now let's check adjacency for C. We can see that it's D and B. We can take any one of the two. So let's take D first. Okay, we are just going according to the figure. You can also take B here. That's not a problem. You can always do that. That completely depends on you. Okay. So now let's push D here into the stack. So A, C, then D, and we are adding it to the output queue. So A, C, D, and marking it as visited. Now we have 4 adjacent nodes of D, C, E, B, F. Now C has already been visited. E, B and F are left. Okay, so now let's go for B so that we can complete this part of the figure, or rather the graph. So we are going for B. So pushing in B, so A, C, D, then B, and we are writing it in the output also, A, C, D and B. Okay, and marking it as visited. Now let's check adjacency for B, and as you can see, all the adjacent nodes of B, that is A, C and D, have already been visited. So what we are going to do now, we are just going to pop out B from the stack, just like that. Okay, so A, C, D and popping out B. So the output does not change, output remains the same, that is ACDB. We just popped out B. Now as we have popped out B, we are left with D as the topmost element in the stack. So let's again check for the adjacency of D, and we can see that we have E and F left. Okay, so let's move on with E. So we are adding E in the stack, so A, C, D, then E. We are adding E in the output queue, so A, C, D, B and E. Okay, now we are marking it as visited. Now let's check adjacency for E, and we can see we have F and G left. Okay, so let's move on with G. So A, C, D, E, G, and we mark it as visited, and add it to the output Q. So A, C, D, B, E, G. Okay. Now let's check adjacency for G, and we can see that the only adjacent node of G is E, but it has already been visited. So we are going to pop out G from the stack. G, and we have E, D, C, A left in the stack, with E being the topmost element. So let's check adjacency for E again, and we can see that we have F left. So let's add, or rather push F to the stack. So A, C, D, E and F. Okay. So, oh, I forgot to write the output, but the output will remain same for this step. Only it will change for this step, that is we will add F here. So A, C, D, B, E, G, F, and it will remain same for this step, that is A, C, D, B, E and G. Okay. So we have added F here into the stack, so we have added F in the output Q also. Now we are marking it as visited. So as you can see, we have already visited all the nodes. Now what's the task left with us? We need to pop out all the elements present in the stack till we reach the last element, that is A. Okay. So after popping all the elements out, we have reached to the last element A, which we will finally pop out, and we will get the empty stack with which we started, and that's the point where we need to stop our algorithm. Okay. So this was the DFS algorithm, and the result of this algorithm is the output, or the result of this algorithm is A, C, D, B, E, G, F. Okay. So this was the result of our DFS, or depth first search graph traversal algorithm. So this was all for this video, guys. Thank you for watching this video. Stay tuned to my channel for upcoming videos, and do subscribe to my channel if you haven't yet, and press the bell notification icon for getting notified whenever I upload a future video. Thank you.